In this question, we are asked to determine first if the pictures shown are pictures of pure substances or mixture. Once we've identified that, we're then asked to determine what the classification of matter is. Namely, we're asked to figure out if it contains elements, molecules, and/or compounds. So the first thing, let's go through each picture and figure out if it's a mixture or a pure substance. All right, so taking a look at the first image on the left, we see we've got some circles going on here that are representing some sort of type of matter. Now, the first thing I want to point out is the fact that you have circles that are overlapping each other. Anytime you see two circles in this image overlapping each other, they are assumed to be chemically bonded together. And so we're not going to treat them as two individual white circles. We're going to actually treat this as just one piece of matter. Same thing for here, and so on. So anytime you see circles touching or overlapping, that indicates that they're chemically bonded, and therefore we're going to treat it as just one thing. So in this first image right here, you can essentially look at it as it has 8 particles. 1, 2, 3, 4, 5, 6, 7, and 8. Now, if you compare all of those 8 particles, are they the same or are they different? Since they all are the same, namely there are 2 white circles that are overlapping each other, we are going to say that this is a pure substance. So let's go ahead and do the same thing for the remaining 2 before we move on to what individually is in each picture. So taking a look at the one in the middle, okay, we got a lot of circles. We got dark circles and white circles, and we need to figure out what's going on here. So sometimes students might look at an image like this and be tempted to think that it's a mixture because you've got different things. You've got dark circles and white circles. But remember, anytime the circles are overlapping each other, that means that they're chemically bonded, and therefore you can treat it as one thing. So for example, right here, you have 4 white circles and 2 dark circles, but they're all overlapping each other, and so I'm not going to view them as single. I'm going to view them as one thing. Same thing here, and so on. So you can view this picture in the middle not as a bunch of different circles, but you can essentially view it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 particles. And the question is, are those 10 particles the same? And the answer is yes, they all are the same. And then so once again, this one would be classified as a pure substance. Finally, let's look at the image on the right. If I look here, we've got some white circles that are overlapping, and so we're going to treat that as one thing. But then you've got these dark circles, and they're not touching the white circles, so they're going to be separate. So if I take a look at what's in the image overall, there's different things. There's black circles that are apart from the white circles that are being combined together chemically. And so, since not everything is the same, this last picture would be a mixture. Now that we've gone through and we've identified what each of the different types of images are representing, pure substances or mixtures, now we need to go through and figure out, well, what's in there specifically. Okay, so let's look back at the first image on the left. All right, first question is, you would want to ask yourself is, does the picture contain elements? Now, there's 2 ways to identify if it contains elements. The first way is to identify, are there individual circles? Individual circles that are just, they're single, they're not bonded to anything, they just represent one atom. And that would be one way of doing an element. Well, that doesn't really apply in this first image since there are no individual circles, everything's bonded. Okay, but if you notice the things that are bonded, it's 2 atoms that are bonded together, and specifically it's 2 of the same atom. Which means whatever these 2 circles represent, whatever element, they must be the same. So maybe it's 2 hydrogens, maybe it's 2 nitrogens, so on and so forth. We know it's the same element. And so, even though this one might not have been as clear-cut, this one actually does contain elements. Specifically, because there are 2 atoms bonded together, it must be a diatomic element. Remember, elements like hydrogen or oxygen, for example, those are elements that they have to be in 2s. All right, now since this is a diatomic element, we would also say it contains molecules. Molecules are defined as being 2 or more atoms bonded together. So anytime you see 2 or more circles bonded together, regardless of whether they're the same atom or different, they're going to be a molecule. Now a compound, on the other hand, that's the third thing we're going to look for. A compound is going to be defined as 2 or more different elements bonded together. Now, how do you know if they're different elements when you're just looking at circles? Well, remember, different color circles represent different atoms of elements. And so since it's the same color, these are the same element. They're the same atom. And so this would not contain compounds. Compounds need to be 2 or more different elements. All right, let's look at the middle one. Does the middle one contain elements? That's the first thing we want to check for. You might be tempted to say, yes, everything has to contain elements because elements make up everything. But that's not exactly what we're asking. We're asking, does it contain elements alone, meaning in an unbonded situation? And that's not what's happening here. You have elements, yes, but they're all combining together to make compounds. So you don't have those single individual atoms just existing on their own, and then you don't have those diatomic diatomic molecules that we saw in the first one. So the second image in the middle does not contain elements. Does it contain molecules? Yes, it does. It contains molecules because remember, to be a molecule, you just have to have two or more different atoms bonded together. It doesn't matter if they're the same or different, you just have to have two or more different atoms bonded together. Specifically, in this example, we have 6 atoms bonded together, here, and here, and here, and so on. So we definitely have molecules. The last question is, do we have compounds? Remember, a compound is going to be defined as 2 or more different elements bonded together. And if you notice, we have this element that represents the black circles, and then this element that's the white circles, and they're bonded together. And so this one is going to contain compounds. Now notice, comparing the first and second image, notice that it is possible to have molecules but not compounds. But it's not possible to have compounds and not molecules because molecules are more general. All right, last picture. Do we have elements? Yes, we have elements that represent the black circles. Okay, those are single atom elements, maybe such as a carbon atom, a silver atom, whatever it might be. But don't forget, we also have the diatomic elements too. So we definitely have elements in that last one. Do we have molecules? Well, the black ones aren't the molecules, but the white ones are. The white represents the molecules here. And so, yes, we do have molecules in the last one. Do we have compounds? Well, we have 2 or more different elements represented in the picture. We have the black and the white, but they're not chemically bonded together. And so we do not have compounds.